And we're starting right now, everybody. Welcome to today's webinar of the WeAreDevelopers live sessions. I'm Vilana and I'm the host of the sessions also this week, surprise, surprise. And today, actually, I'm very happy because I'm really not alone here and I'm going to have a co-moderator of the session. And before I introduce him to you, actually, I just want to, as always, to go to the house rules because this is a live event. You can write in the comments everything. And just before we start with introducing ourselves, to remind that this event is inclusive and it's we want that everybody respect each other in the chat section. So please comply with our code of conduct. You can find the link already posted in the public chat section. Another thing that we always invite you to do is actually to introduce each other. Go ahead and write right now in the comments where you're watching us from and what do you do. Tell us what your interests are and how excited you are actually for this session to happen today. And last but not least, you see also on the right side on the chat section a question mark, and this is where you can put your questions during the presentation and they will be answered at the end. So throughout the whole sessions, if you have any questions, just type them there so we have them separate and selected, and then it will be very nice and easy to be answered at the end of the session. And yeah, I think I covered pretty much everything that you should know in order to start this session right now. And I'm going to hand over to Dragan, our friend from Debug in Croatia, and he will introduce you who is the speaker today, what are we going to be talking about, and then also moderating the Q&A at the end. So I will be just here for the logistical part of the event. And with this being said, I'm going to hand it over, mute myself, and yeah, let you enjoy the session.
Thank you, Ilana, for the intro. Good afternoon, everyone. I see a lot of attendees today from Croatia, but from the rest of the world as well. So just a few words about the Bug. It's developers conference produced by Bug, the leading tech magazine in Adriatic region. And although it was held for the first time in December last year, it was the biggest developers conference ever held in Croatia. I'm managing director of the Bug, and I'd like to emphasize that partnering with WeAreDevelopers was an important part of our success. We've been working with WeAreDevelopers as media partners for years, so it was only natural for us to extend that partnership to conference. Instead of being competitors, the Bug and WeAreDevelopers are partners, and today's session comes as one of the results of that partnership. So we do hope we will be able to hold the Bug this December as well. We are ready, of course. We just need circumstances to allow us to get together again in person. Until then, you can enjoy a lot of great virtual sessions by the Bug speakers, by WeAreDevelopers speakers, starting right now. Since Denis Jajčević from Kroz was one of the best rated speakers at the Bug in December, and since Kroz is one of the most respected IT companies in Croatia, I'm sure you will be delighted. So Denis, just a quick intro. Your job in Kroz is exactly what?
I'm a DevOps engineer at Kroz, and
okay.
I do DevOps.
Okay, and the title of today's session, everybody knows it already, but let's just repeat it.
Yeah, we're going to talk about real-life showcase of introducing cloud-native practices in enterprise environments.
Cool. I will not bother everybody anymore. So Denis, the virtual stage is yours, and I'll be back with Q&A session at the end.
Thank you. Hello again, everybody. As I said before, I'm a senior DevOps engineer at Kroz. And I will try to share my experiences from helping a telco company, IAN Telecom in Croatia, implement cloud-native DevOps practices. So what made them call Kroz? Well, there was a mission they decided to accomplish. The mission was to use OpenShift as a platform for their applications. And that's a great mission, right? But it comes with a price. You need DevOps, and Kroz has some experience with DevOps. good guy most of the time. For the purpose of the sharing experiences, we'll not go into deep into DevOps. So what is DevOps? So whole internet knows him, and I'm sure you've stumbled now and there upon him at least once. So to get back on track, to make best use of OpenShift platform and gain benefits, most companies needed to change their approach in developing, but most importantly, how they deploy their applications. Developing cloud-native applications can be very daunting, but with right set of well-defined procedures, practices, and guidelines, it can turn into a joy. So let me try. Okay. What's the first thing? So we started by analyzing current application development processes and what steps are needed to deliver developers code, build it, and finally deploy it. Everything has to go through a ticket, and it's a good thing. Each decision or change can be traced. The bad thing is that we are going through a lot of states in that ticket and a lot of waiting time between them. So developers could wait for days for the changes to be available to testers, and after that, a few more to deploy it into production. That could end up being in weeks, and that's a lot of time for developer to get feedback for the change, right? So reaction to production problems and time to market thingy is what we needed to focus on. Aside from development and code delivering processes, the deployments are made in various ways, mainly manual. Not saying that that's a very bad thing, but in terms of circumstances, it's what they are doing now. So there are manual SCPs to service. There are manual environment configurations. There are manual builds. I know many of us are using and doing it right now. So it's obvious that all that are manual tasks. Even with the following step-by-step guides, those actions are very prone to errors. Each repetitive task can be done wrong. So we're humans, and our fatigue varies from throughout the day, from hour to hour, and we're unfortunately make mistakes. So manual SCPs depend, so to go through all three of them, depend on, like this conference, on internet speeds. If binary upload is done from, let's say a developer's laptop. So if your VPN breaks, you go again. So you have to upload it again. So it's very it's very difficult to upload that application when you're viewing from your slow internet connection. Manual environment configurations updates could depend even on how you indent lines in configuration files. So for example, if you use tab instead of space, or if you use 3 spaces or instead of 2 spaces, it's very error prone, and those configuration files can lead into disasters for production environment. Those configuration files a client has stored in a separate Git repository available only for a few people from dev team, so it's kind of separated from a need-to-know basis into need-to-know basis. So about builds, manual builds, you know how it goes. It depends if you're using the same toolkit. Depends if you're using the same Java version for building Java applications, using same Gradle or Maven versions. You're using probably the same OpenShift. These are all the factors that can affect the how end artifact is built. Not to forget do we skip tests? Can we perform tests? These are all tough questions, and unfortunately nowadays this is not good, right? These manual tasks are part of legacy, and customer is aware of them not being the best way. Everybody has their reasons. There's really no need to judge, but every company is facing undesired employee fluctuations, and that leads a lot of cuts. I think that's the main reason why we are not doing or have a hard time following the best practices nowadays. So therefore, we decided to find a better way. What we did, what did we do to get better? Right there, let's talk about that. So the first thing we endeavored was to connect devs and ops in some way better than it is now, since there was an obvious lack of communications between them. So we decided to do sort of two sessions, separate sessions, where we sat with developers and ops in separate workshops. So with developers, we sat and listened to their problems. The most mentioned was the time to deploy their changes. The second was that they depended a lot on ops for runtime environment, and they're having a difficulty tweaking their application performance without going through a lot of procedures. The best example is, for example, upgrading Java versions on servers in order to comply a certain security patch. So they wanted to be able to deploy and get feedback as quick as possible. On the other seat, we're also set with ops. At that time, that those ops guys were actually a system administrator assigned to manage OpenShift platform and listened to their problems. So I think you it's now the correct slide. So with picture, I think you will understand what's the main problem with ops. The over-the-wall problem is the one thing that's causing ops a headache. When they get a binary to deploy, they're on their own. They need to put down the one server on application on one server, pull down the balancer, replace the binary, update configuration, start the app. If it's not working, roll back and report the developer by, I don't know, updating a ticket. If it all went well, do the same thing on the other server, all this in the same steps, put down the balancer, replace the binary, start the app. If it's all good, great, you're done. But without clear instructions from, it's clear that in this scenario, its ops needs clear and appropriate instructions of what to change in configurations and how to start the app. So over the wall, when developer tosses artifact to deploy, ops really needs devs to deploy that application in a safe and reliable way. So in order to shorten ops reaction time to devs requests and the other way around, we needed to make communications better and easier and faster, obviously. We needed, so we declared two virtual teams. One is platform team, the other one is feature team. Platform team manages a platform, that being everything involving building and deploying applications, defining procedures, best practices, even onboarding feature teams, and everything involving platform. So feature teams, on the other hand, are the consumers and users of that provisioned platform, and they are responsible to deliver their tested and platform compliant code to build system to deploy their changes. So the idea was to have a platform team to prepare the workspace for feature teams to use without needing the ping platform team for everything. And as you might figure out, that was pretty much the easier part. The hard part begins when we try to define that process that developers and platform teams need to develop. So we could just use the tools we had, but we took a different approach of defining how process needs to look like and find the tools that will fit the picture. Use the same ones, update them or reconfigure them or install new ones. Just automating human tasks would result in an automated mess without a clearly defined process. So the focus was really on to define the easy, simple, easy to understand and simple process that everybody could understand. So the solution was that platform team need to in order to make easier their lives in doing their jobs, we needed to incorporate infrastructure as a code patterns. So we needed to ensure that OpenShift is installed with Ansible playbooks. We needed to have OpenShift installed on the same way as with all environments. We needed to configure OpenShift role-based access to use to connect roles from OpenShift to ones in AD. So, and do that in a repeatable way with Ansible playbooks. We needed to, I'll talk about it a little more later, install and automate installation and configuration of Argo CD GitOps tool. And we needed to have it all on our Git repository that is visible to platform thing, so we can track changes, we can track upgrades, we can do it from anywhere, right? We don't rely on that code being resident on single machine that is invoking it. This way, we are closer to sort of desired disaster recovery plan. So we can, if it comes to that, if some data center went down, we can bring up another one and play playbooks and get the same environment that we had on the one that failed. So the next thing was obviously to define a DevOps pipeline that is actually deploying that and delivering that code to environments. So after appropriate platform setup, we've defined 4 steps pipeline by using Jenkins pipelines, and using pre-built Docker containers specialized for all except the second step. There are 2 defined Git repositories in play here. One is for the application source code, obviously, and the other one is for the application configuration repository, which contains OpenShift resource definitions that are used to apply and configure application on OpenShift. So let's go through all DevOps pipeline steps one by one. So the first one is obviously the build. It is a process that clones application source repository, checks out a release branch, and builds an artifact. Later on, that we come to containerize step. That is a process that creates a Docker image or packs a container with prepared artifact from the previous step by using Docker file from a source code repository. Now we go to when we have a Docker image ready to deploy on OpenShift, we patch deployment configuration with that image and put it back on Git repository. And after that, we ignite Argo CD configuration sync that actually applies that patched configurations on OpenShift. And with the OC tool, we follow the rollout, the app rollout, and if it is successful, the pipeline goes success. If it failed, the pipeline failed. That's for the, for example, test environment. For production environment, this story is the same. So we deployed the same built image and tested the image from test environment on production environment, but only we are on a release step. We are actually checking out the production version of configuration, patching that, replacing that image, and syncing the configuration, and therefore deploying that application on production environment. So that's basically those 4 steps are. We try to keep it so simple and focused for tasks, and reuse Docker images so we can, if we decided to go to another pipeline tool, we can migrate easily. So now we are in the phase where we have a automatic deployment. So we're not now we're not deploying manually. So we had the well-documented procedures and guidelines. There's a little need for platform to be involved in application lifecycle. So platform team, when it creates a namespace and a project, its job is sort of done. So there's no need to platform to involve in deploying application. Application lifecycle now is managed by a feature team, but with limitations enforced by a platform team. Platform team sets the limits and quotas on namespaces and what feature team can do with that namespace, and from there on, feature teams can use and deploy that namespace and deploy applications in that namespace. So the thing that is left is how developers do configure their application. So as Kelsey Hightower said itself, that world is envisioned as a repo and as a Kubernetes installation. So everything is now in Git. So we're trying to have everything versioned, have everything tracked. If we can change changes, we can do more restrictive access to configuration files. So we're putting everything we can in Git repository, and that is some way a good and a bad thing that we'll talk about later. So for that, since we are using Git, so actually we are trying to use GitOps practices, we found that Argo CD matches everything we need now. So if we want application definitions and configurations, environments, declarative and version controlled, we'll use Git with Argo CD. So if we if we want to application deployment and lifecycles be auditable, and easy to understand, we'll use Argo CD. So I won't go much more in Argo CD, but if there's a lot of issues on the internet, but if you want to, you can DM me or something. Argo CD is a great tool if you opt to use GitOps. So what we did finally, in all, so we improved platform automation. So platform teams now install and configure Argo CD, build tools, and OpenShift with Ansible. So there's a little to no human error that something can go wrong. We automated build, containerization, release, and deploy of applications. We automated OpenShift project configurations with Argo CD, and those configurations are stored in Git. Also, on the same principle, we automated OpenShift apps configuration. So if we go with OpenShift resource definitions, project configuration is a namespace, quota, and limits. And with OpenShift apps configuration, these are, let's say, deployment configurations, routes, services, config maps, secrets, and so on and so on. So we leveraged the Git benefits. So we use a branch per environment, so we can distinguish what is test, what is production, and use merge requests when migrating from test to production. Right? So environment propagation is done by merge requests. All in all, architecture looks a bit like this. I don't know how it looks like on a bigger screen. I don't know. But we have Argo CD that is automating provisioning of applications and namespaces. We have Jenkins that builds, releases, and starts deployment with Argo CD. We have Artifactory as a artifact store and a Docker registry. We have OpenShift as a platform to run those applications, and GitLab to store those configurations. So if you can see in the picture, we're using the same image on test environment and on production environment, and the only thing that is different is that are using the test or production branch of configuration files. All in all, we're basically we got rid of any manual tasks. So if we look back this slide, we can see that we gained a big thing. So, and that's the ability to deploy changes with just a commit and the push to a repository. No more week-long waits for ops to deploy our code. So there's no constraint other than business ones that could limit number of deployments per day. The developers get an in-time feedback from testers, and development processes can now be a lot faster. Customer is now able to try out customer A1 is now able to try out new features more frequently with small time to market. So developers can do their job with less stress, which is very important, and more joy, more importantly, when they can deliver their changes a lot quicker and more frequently. But as I said, since we're using Git and GitOps principles, it kind of sounds it's too good to be true, right? Frankly, there's one big problem when using GitOps practices, and that Git repository is a single point of failure. If it is unavailable, we can deploy, but neither we can build, so we're good, right? Without proper checks on configuration files, we could end up putting down the whole cluster. Somebody without revision can change to the pod count to, I don't know, scale it to 100, and the whole cluster goes down. Be it WAS, be it OpenShift, be it AWS or Google. And we with how to mitigate that is pull requests. So we're all using pull requests for production, right? Which we should, right? So to conclude, did we succeed in our mission to make stuff easier to deploy, connect devs and ops, and create a new environment for developers to express themselves, to find the right tool for the job? But we did. I personally think we did. We eliminated all manual tasks, automated almost everything, sped up deployment, gave developers freedom, and most importantly, we track all changes through Git. And that's the thing I think upper management is happy for, and we are safer now since there's no ghosts in system that could change the code. And that's it for now. So if anybody has any questions, I'm here. You can go in Q&A mode, or if I don't know if there's any questions.
So thank you, Dan. This was really interesting. We have a question of technical nature. Will the recording be available after the event ends? Yes, it will. Usually it's available the day after. So if anybody has a question for Denis, you can just write it down here in the chat section. Or a comment. It doesn't have to be questions. So if you have anything to say to Denis, please, this is your opportunity now, or be silent forever. Okay, so somebody is typing. Let's just wait a second to see.
Okay.
Okay. Okay.
Okay.
Okay. So should I read the question?
Could you publish and I'll read it.
Okay. Okay. No.
Okay, so just click publish.
Publish. Okay.
So how do you manage sensitive data like passwords? So there are a couple of ways, but the best one depends on how the level of security you want to have for the sensitive data. So there are tools that you can install on OpenShift that will create masked secrets and keep those secrets masked in Git repository, which will be with the operator decrypted at runtime, right? So you'll have encrypted passwords in Git and encrypted at runtime. That's the one option. And the other option is Vault, right? So if you have an option installing Vault, it's a good way to go. So if you don't have an option to keep secrets outside cluster, outside OpenShift, it's better to go in tools to encrypt secrets.
Okay, so we have another question. I will publish it now.
Mm-hmm. Any experience with Azure DevOps and your thoughts? Unfortunately, no, but I'm sure other members of my team did. So fortunately not.
Okay.
Sorry.
Do we have any more questions? Nobody is typing. Going once, going twice. Okay, somebody is typing. Let's just wait for another question. Ta-da-da-da-da. Let's see. Okay, I will publish it. Here is the question.
Where do you store documentation? Documentation, you mean, okay, if you mean a documentation about processes and practices that feature teams have to comply, since it's customer has already installed Confluence, it's stored in Confluence.
Okay. I have one more attendee typing, so let's just wait for another question. Igor is typing, so we're gonna wait for his question as well before we finish. Come on, Igor.
While I'm waiting, we're waiting for the questions. There's on T-shirt says 0800 DevOps, so I encourage you to go. There's a link on the last slide. I'll show it to you when we end up. If you go and subscribe for our blogs, whatever, we'll be very happy to read our stuff. There are a lot of good stuff.
Okay. In the meantime, we have a question. Mm-hmm. So here it is.
Can you touch base about cloud-native services except classic Kubernetes Docker, like cloud-native databases and queues published cloud? Touch base. Let me read a question again. I don't think I understand touch base. You mean explain basics or
explain, or just mention with a few, explain with the few short sentences about cloud native services?
Except like cloud native databases. Okay. There are databases that are cloud native and support and are able to run in Kubernetes. Unfortunately, from my experience, it is often the best way not to run those databases inside Kubernetes. It's a lot safer to have it as a separate cluster on their virtual machines, and the same goes for message queues or anything else. I don't know if what you meant with publish subscribe in case of in terms of Cloudnative here, but if you could ask another one in more details what you meant with the publish subscribe.
I got a message
what you need to know.
from Igor. I got a message from Igor. So he said he's interested in best practices and using managed services from cloud provider versus self-managed.
Oh, it's now much more clear. Well, if you have the money to use managed, go for it, because they have already experienced all the bottlenecks, all the problems, all outages. You'll have to face it on your own. So if you have an option to go with the managed services, it's probably the best way.
Okay, and we had a question from Tomislav. Did you write one? I don't know what's he referring to.
I know. He referred for documentation. Yes, since I was the main author of the procedures and all the documentation that ended up in Confluence.
So
Kubernetes or OpenShift? I would go with OpenShift, since it leverages some stuff that Kubernetes with on bare hands you have to do with your own hands. OpenShift uses, and I say upgrades Kubernetes with few easier for developer stuff.
Okay, thank you, Denis. I see no more questions, so thank you.
I'll just want to show the last slide, sorry.
Okay.
The one with the link. So if you visit bit.ly at 0800 DevOps, I'll be more than happy.
Okay. So Tomislav wants me to publish this for the end. It's not a question. It's just a statement that he's a handsome guy. But but we have a question from somebody. If you can share slides, where can people get slides? On this link?
I think no. I think we'll have to ask Lana.
Okay. Cool. Thanks everybody for attending. So Vilana is back with us. And
yes, I'm back. Regarding the slides, just to answer before we finish, the best is, I think, if Denis will send us the slides and then we'll put a link under the recording on YouTube for them. Or if you, Denis, make them public in some kind of a platform like SlideShare or something, just send us the link. But we'll figure them out. And in the worst case, if you don't get access to download them, you can always see them in the recording that we're going to publish. So
Okay.
you will for sure see the slides again. And yeah, thank you very much both for actually participating, for having you here. For us now, it's actually time to tell you.